Welcome to Educhemist's episode on the WAEC series. So today we will be going through an important topic in physics for the WAEC student, practical physics. And we go through how you can prepare yourself adequately for the forthcoming WAEC physics practical. So we're going through some very important rules that will help you write your WAEC physics practical. So let's get into it. So we'll begin by looking at experimental procedures and basic measurement. Now, how to perform and report experiments for the WAEC exam. So the first thing you have to look at is the laboratory requirement. So every student must come to the laboratory with a mathematical set, a ruler, a sharp pencil, an eraser, a pen, and a calculator. So you have to write the number and title of the experiment and the date on which it is performed. For the WAEC purpose, what you will be required is the title of the experiment. The instructions are given on how you set your apparatus. So if you read the instruction carefully and follow through it and set it up the way the diagram has been given. So check that the set of apparatus provided is complete. Lay out the apparatus neatly in such a way that you can take your readings conveniently. In case of an electrical experiment, invite your teacher to check your connection before switching on the circuit. Draw a simple label diagram of your setup, and this diagram, you don't need to draw it for the WAEC. The diagram will be given to you, then you follow to with the setup. So the readings, so you read the instructions very carefully and ensure that you are making the correct measurement. Remember, no marks will be awarded to you for wrong measurement. And this is how so record, these are the steps when taking your readings. Record each measurement as you make it. Repeat every measurement and record it. Then take the mean values of the recording. So let's say you are taking the time oscillation. Let's say T1. So here is T1, here is T2. So you take the mean of these two. That's T1. That's the average over 2. So that is what that slide is telling us to do. And then, whenever possible, record your readings and results in orderly composite table. Remember to insert the appropriate unit of the measured value, and it is necessary in every measurement to indicate the degree of accuracy of the measurement. And this degree of accuracy will depend on the scale of the instrument used. And it is indicated by the number of significant figures or number of decimal places to which the value is given. So let's say, for example, if we record a certain value, a certain length as 2.65 centimeter, then we have used a scale which reaches the nearest 0.05 centimeter. That is, the 0.05 centimeter is the reading accuracy of the scale. So sometimes we have some derived readings. So having obtained series of direct readings, say X and Y, you can get your derived reading. All the derived reading instructions are given to you on how to get them, and that's what you fix to make your table of value. Sometimes we have a direct reading, say X and Y. the hybriding may be the inverse of x and y, the square of x and y, the square root of x and y, or dividing both of them. So those, or getting the logarithm of those, or the exponential of those are derived readings. So another important thing you need to know is the graph. Graph is very important. Very important. The graph is very important. And when doing graph, you should note down the following. You should note down the following point. So you must choose a suitable scale for your graph. I will get deep into choosing these scales for your graph. So you must have a suitable scale for your graph. And what we mean by that is your scale should be such that it can be used directly and easily without auxiliary calculations. So scales can be written as maybe 1 centimeter represents 1 unit. Or we can have 1 centimeter to represent all this, so you can have 0.1 units, 0.2 units, you can have 0.5 units, you can have 2 units, you can have 5 units, you can have 10 units, like that. Or sometimes you can use 1 centimeter and 2 centimeters to represent the same. So avoid using scales like this. So avoid scales like this. Avoid using scales such as 2 centimeter represent 5 units. Avoid such kinds of scale. Or 1 centimeter to represent 3 units, or its multiples. These are not suitable, so these are unsuitable scales. So avoid these ones. These are suitable scales. So also another thing you should note concerning your graph is that your scale should occupy at least 1/2 or half of the graph. So cover at least 50% of the graph, and the points should be well distributed throughout the graph. The points should be well distributed throughout the graph. So another thing we'll look at is that the quantities you plot on the graph must be clearly and neatly indicated with units. Quantities plotted on the graph must be clearly and neatly marked, or be clearly and neatly marked with crosses, X, or plus sign. Or circle, or even dots. These are the 4 Your pencil must be sharp to be able to do that. Pencils must be sharp. Another thing you have to consider is that use large right angle triangle to evaluate the slope. So for the slope, use large right angle triangle. Large right angle triangle to evaluate your slope. And you must show clearly how you obtained your answer. You must show clearly how you obtain your answer. So use a convenient denominator. Choose points that are easy to locate and are not ambiguous. So your slope is given by the formula. Slope is change in y, but change in x, which is y2 minus y1 over x2 minus x1. And slope can be, another name for slope is the gradient. So take note. Another name for slope is the gradient. So if only the slope of the graph is required and not the gradient, if only the slope of the graph is required and not the gradient, and not the intercepts, it is not necessary to start the graph from the origin. So not all graphs need to start from the origin. Not all graphs need to start from the origin. This is when the intercept is not required. This is when the intercept is not required. If the intercept is not required, so you don't need to start the graph from the origin. So another point you need to know is on your precautions. Very important. So precautions are very, very important. So at the end, for your WAEC, you'll be asked to write down the necessary precautions taken to have accurate values. So at the end of the experiment, it is important for you to state all the precautions which you took and obtain accurate results, even if you were not asked to do so. So where possible, give reasons why the precautions are necessary. So now we'll look at graphs very, very well. We'll go deeper into graphs, and now we can handle the data. Graphs and data handling. Yeah, let's see. This is very, very important. So in your physics experiment or practical physics, it is never enough to rely upon a single measurement or calculating a particular quantity. So a more accurate result is always obtained by taking many measurements and then plotting a suitable graph. So what's a graph? A graph is very important tool for analyzing your experimental results. So the graph is just a plot of a particular variable against another variable, mostly a plot of the dependent variable against the independent variable. So, and we have so many types of graphs that you will come across in your practical. So we have the straight line graph. We have the straight line graph. We have the quadratic graph. Quadratic graph, inverse graph, We have the inverse graph. We have the exponential graph. Exponential graphs. So this exponential from these three are mainly curves. Yeah, these three are mainly curves. Okay. So this is very, very important. So let's look at the straight line graph. Straight line graph. Let's look at the straight line graph. Straight line graph. The straight line graph. So for the straight line graph, we have a general equation y equals to mx plus c. Ym is the slope or intercept or the gradient, and then c is the intercept on the y-axis. That's the intercept on the y-axis. X and y are variable. So this slope m can be seen as tan theta, and mostly, which is y2 minus y1 over x2 minus x1. Yeah, I will draw a graph like this. This is just a rough sketch. So if I get a triangle like this. So if I trace this down and trace this down, so this is how you get your point. This is your y2, this is your y1. Trace this down, this is your x2, and this is your x1. So the angle here is theta, and that slope is tan theta. Remember, tan theta is opposite, which is the change in y, over adjacent, which is the change in x. And this is what we call the intercept from here to here, where the line crosses the y-axis. That's the intercept. Where the line crosses the y-axis is called the intercept. So it's from here to here. So this is the intercept, where the line crosses the y-axis. So for this graph, we have special cases. We have special cases. What are these special cases of? So the first case is when c is equals to 0. So when c equals to 0, we have that y equals to, remember our general equation, y equals to mx plus c. C is now 0, so our y will be equals to mx. And what does this tell us? That the line is passing through the origin. That's what it means. Line passing through the origin. Then the second case is when m is equals to 0. Let's write our equation, mx plus c. When this m is 0, we left with y equals to c. And what that means is that we will have a line that is parallel to the x-axis. And it's cutting the y-axis at a distance c. another case is when the slope is equals to 1. So when we have the slope when m equals to 1, and when m equals to 1, we mean that the angle is 45 degrees, because tan 45 degrees will give 1. So when we have that m equals to 1, let's say mx plus c. So we have that y equals to x plus c. So let's say, okay, and let's say c equals to 0. So if c is 0, yeah, so we have that y equals to x, yeah, c equals to 0. So we conclude that y is equals to x. Now, what does this equation mean? It means that the line is passing through the origin and making an angle 45 degrees to the x-axis. So line passes through the origin and makes 45 and makes an angle of 45 degrees with the x-axis. So the next, let's say, is very important when the equation y equals to 0. So when we have the equation y equals to 0, what means that it is the line is along the x-axis. When we have that x equals to 0, we have that the line is along the y-axis. And when we have another equation, we have the equation that x is equals to k. So we have a line that is parallel. The line is parallel to the y-axis and cutting the x-axis. And cutting the x-axis at a distance k from the origin, actually. So let's summarize this. Let's summarize all these points. If we have our graph like this, when we have the angle is 45 degrees, just like this, so we have the equation that y is equals to x. Have this is a straight line, so this gives us when y equals to mx, and then we'll have something like this. When it's parallel to the x-axis, we'll have y parallel to the x-axis, y is equals to c. And this is our c, the distance from this is the c here. And then we can have another line like this, a line like this. Let's parallel to the y-axis. Don't mind my line parallel to the y-axis. Parallel to the y-axis. So we have x is equals to k there, and then this k is the distance from the origin, and this is the origin. So we can see the different conditions here. So how do you measure the intercept? How do you get the intercept? So if the intercept is required, the graph must start from the origin so that you can determine C directly from the graph. Very, very important. Very, very important. Now, one skill that most students neglect is this one that we're going to do next. Conversion of equations of physics to straight line form. Very important. Conversion of equation of physics to straight line form. Very, very important. And this is a problem of transformation. So we're transforming equations into a linear form. So I'll give an example to give us an understanding of that. If we have t equals to 2 pi h minus L over G, where t and L are variables and G and H are physical constants. So G and H, this is a constant, and this is also a constant. This is a variable, and this is a variable. 2 pi we know is a constant. So let's say we are plotting the graph of, we're plotting a graph of t against L. If we plot a graph of t against L, it will not give us a straight line curve, not a straight line, because this is not a linear equation. If we look at it, it's not a linear equation, because we will have something like a square root. And remember, for a linear equation, the highest power of x is 1. So x is 1. So the highest power is 1. So the power of x is 1. The power of x is 1. So any power that is not 1 makes that equation not linear. So, and we can see that here. So what we do for us to have a straight line graph is to transform that equation into a linear equation. So I have this. Let me bring back that equation. T equals to 2 pi equals square root of h minus L over G. So let's square root both sides. It will square both sides. Let's square both sides. Meaning squaring both sides means like this. Square both sides. So I have t squared. 2 pi squared will give me 4 pi squared. And then this cancels this root. So we're left with h minus L over G. So let me expand. We have 4 pi squared h over G minus 4 pi squared L over G. So we've transformed this equation. So let me rearrange the equation. T squared equals minus 4 pi squared L over G plus 4 pi squared H over G. Why do I have to? All these are constant values, so it will fall under the intercept. So it's the intercept. So we compare this with y equals to mx plus c. We can see that this c is the intercept. You can see, and that this is the slope. So what does that tell us? So the new graph we are plotting is not, so the graph we plot now will be graph of t squared against L. So where our slope now is minus 4 pi squared over G, and the intercepts, the y-axis will be 4 pi squared H over G, 4 pi squared H over G. So this is how graphs are being transformed. So very, 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 very important. Now let's see another transformation of graph. So I'll put the variables in brackets. So let's say 1 over u plus 1 over v equals 1 over f. So let me put the bracket. The variable is u and v. So that's when f is a constant there. So if let's transform this equation such that what are we going to plot on the y-axis and what are we going to plot on the x-axis. We've been given our variables, because if we plot the graph of u against v or v against u, we will not get a straight line graph. Yeah, because if we write this equation, we have u minus 1 plus v minus 1 equals f minus 1. So this is not linear. So let's transform it to a linear graph. So for us to have a linear graph, remember a linear graph equation is y equals to mx plus c. And what do we have in our equation? We have 1 over u equals to 1 over v plus 1 over f equals 1 over u plus 1 over v. Now let's compare. Remember, this is f is a constant. The only variables we have there are u and v. So we cannot plot a constant against a variable. So we can rearrange this equation. So 1 over u minus 1 over, or let's say, let's rearrange this equation and say, let me take this to the other side. So 1 over v becomes 1 over f minus 1 over u. And remember, our constant goes to the intercept. So I can rearrange 1 over v equals to minus 1 over u plus 1 over f. So if we compare it with the linear equation y equals to mx plus c, you can see that the y-axis is 1 over v, and the x-axis equivalent should be 1 over u, and the intercept is 1 over f. So what we have now is that our slope m is minus 1, and the intercept c equals 1 over f. Okay, let's see another. Finally, question 3. So let's see a graph. Let's say y is equals to axn, where the variables are y and x. The variable are y and x. Can see this is from that equation we already know that it is not a linear equation. So how do we transform it? How do we transform that? For us to transform this type of equation, let's get the logarithm of both sides. So log y is equals to log a plus log x raised to the power of n. So we can see that log y equals to log a plus n log x. Now remember, our variables are y and x. That means this is a is a constant. So I can rearrange this log y equals to n log x plus log a, and then compare it with the linear equation of y equals to mx plus c. So we can see from here that this is y, log x is the x, and then the intercept is this. So that means our y-axis, so the y equivalent to be log y, so y equivalent to be log y, the x equivalent to be log x. So the slope, which is m, becomes n, and the intercept c becomes log a. Wow, beautiful. I believe we've gotten value from today's physics practical. I believe we've gotten value from there. Another last thing that you will see is how to draw your table of value, but we'll do it in our next video, where we'll be taking a WAEC physics practical question, and I'll guide you through the steps in plotting the graph, choosing the scale. So that will be more practical, but this is the theoretical aspect of it. I'll see you in our next class. Bye for now. Don't forget to like and subscribe, and click on the notification button so that you can get more engaging content from the Educamics Virtual School. See you in our next episode, and bye for now.